Today we're going to talk about matrices. So first I'd like to go through some definitions so that you know what a matrix is. A matrix is any rectangular arrangement of numbers in rows and columns enclosed by brackets. As you see down here, this would be a matrix because it is a rectangular arrangement of numbers in rows and columns enclosed by brackets. The dimensions of a matrix are the number of rows by the number of columns. So as you can see, our matrix has 2 rows. Rows go across, and 3 columns. Columns go up and down. So it is a 2 by 3 matrix. And we call each number an element. That is each number you put into the matrix. So, if I wanted to know what element was in row 2, column 3, row 1, row 2, so I'm going to be down here, column 1, column 2, column 3. Row 2, column 3 intersect right there, so it is 5. Let's just try another one. What if I said element in row 1, column 2? Row 1, column 2. Column 1, column 2 would be right here. That would be equivalent to 2. Now we have all kinds of special matrices. The first I'd like to talk to you about is called a row matrix. And remember, mathematicians call things as they see them. The reason it's called a row matrix is because it is a matrix with 1 row. And here is an example of it. You see there's only 1 row and 4 columns. So on the other hand, a column matrix would be a matrix with 1 column, as you see here. A square matrix is a matrix with equal number of rows and columns, a matrix with equal dimensions. As you see here, this is a 3 by 3, 3 rows and 3 columns. A zero matrix is a matrix whose entries are all 0. Notice how it's denoted. That is a 0, 3 by 2. So that means 3 rows and 2 columns. And all the entries are zeros. If matrices are considered equal, that means first their dimensions are equal, and then every entry that corresponds is equal. So for example, this is a 2 by 2, and it is equal to another 2 by 2. As you can see, the first entry is 5, and the first entry is 5. The next entry in row 1, column 2 is 0, and the same in row 1, column 2 of the second one. The next entry in row 2, column 1 is negative 4 divide 4, and that is equivalent to negative 1. And then the last entry is 3/4, which is equivalent to 0.75. So the key here is that every corresponding element is equivalent. And last, we have what is called our identity matrix. It's a square matrix with a diagonal of ones. So notice here is a 3 by 3 matrix. And do you notice this first diagonal is all ones? Every other element is 0. Now, if matrices have equal dimensions, not only can they be set equal to each other, but that is when we can apply the operations. And the operations we're going to look at are adding and subtracting. But in order to add and subtract, first your matrices must be of equal dimension. So let's check out this matrix A. This is 1, 2, 3 rows by 1 column. This is also 3 rows by 1 column. So I should be able to add them. And how I add them is element by corresponding element. So the first would be a 0 plus 1. Next is a 4 plus negative 9. And last is a 3 plus 8. So that results in 1, negative 5, 11. In problem B, my matrices are a 2 by 2, and I'm subtracting a 2 by 2. So that should work. So row 1, column 1 minus row 1, column 1 is 3 minus 2, which is 1. Next, 3 minus 0, which is 3. In row 2, column 1, 9 minus negative 3 is 12. And last, negative 5 minus 5 is negative 10. And in problem C, I have a 1 row by 2 column matrix and a 2 by 2. So this will not add. It is not possible. And I'm going to show you that. I can take row 1, column 1 plus row 1, column 1, and I would get 10. Row 1, column 2 plus row 1, column 2, I would get negative 4. But now, there is no element in row 2 because there is no row 2. So it leaves me empty-handed. This is empty. So I have no value to add to my 4. So that is why it is not possible. Then we have what's called scalar multiplication. If you recall in geometry, you had a scale that you dilated by. Either it was 2, where every coordinate became twice as large, or it was like a third and every coordinate became a third as large. Well, the scalar is the number in front that you multiply by. So when you have a scalar, you must distribute that through to each entry. So in this problem, A, 6 is my scalar. So I must distribute the 6 to every one of these entries. So as a result, it means 6 times 2, 6 times negative 3, 6 times 8, and 6 times 4, which actually gives me the matrix 12, negative 18, 48, 24. In B, I have a scalar of negative 1, and then I'm going to add it to this 3 by 2, Well, this is also a 3 by 2, so it should work. So first I'm going to do the scalar. So it becomes a -4, 7, -3, -3, -2, 9. And then I'm going to add it to 3, 6, 9, -8, 1, -4. So when I add that, -4 plus 3 is -1. 7 plus 6 is 13. -3 plus 9 is 6. -3 plus -8 is -11. -2 plus 1 is 3. And 9 plus -4 is 5. This next one has me first add and then multiply by a scalar of 4. And then I'm going to set it equal to this 2 by 2. So I'm just going to carry this scalar along. When I add 8 plus 4, I get 12. 0 plus -2x is -2x. -1 plus 1 is 0. 2y plus 6 is 2y plus 6. Then I'm going to take this scalar of 4, multiply it by each of these. So I get 48. 4 times -2x, -8x. 4 times 0, 0. 4 times 2y plus 6 is 8y plus 24. And that matrix should equal 48, -48, 0, and 8. So every element should be equal. 48 equals 48. That is true. Then I have -8x equals -48. So I'm going to write that over here. I can then solve for x. Divide by -8, and I get x equals 6. Next I have 0 equals 0. That is true. And then I have 8y plus 24 equals 8. So again, something for me to solve. 8y plus 24 equals 8. Subtract 24. 8y equals -16. Divide by 8. Y equals a -2. And we're going to do a story problem that involves matrices. It says condominium owners paid yearly fees to cover the costs of maintenance, landscaping, and remodeling. The fees this year were $96, $18, and $66 for a one-bedroom unit, and $128, $24, and $88 for a two-bedroom unit. The fees next year are $105, $20, and $73 for the one-bedroom, $141, $26, and $97 for the two-bedroom. Use matrices to organize the information. Find the monthly changes in fees from this year to next year. So if I'm going to find a change, I'm going to have to subtract. So I'm going to take next year and subtract this year. And I see that I had one-bedroom and two-bedroom units. And I had the three costs of maintenance, landscape, and remodeling. And this should organize my matrix. So next year, is on the bottom here. 105, 20, 73. And 2-bedroom, 141, 26, and 97. And then I'm subtracting this year's, so I should organize it the exact same way. So this year I had 96, 18, 66 for the 1-bedroom. And 128, 24, and 88 for the 2-bedroom. And this sets up how I'm going to compute it. So now when I do that subtraction, I should get 9, 2, 7, 13, 2, and 11. Nope, and 9. And I'm going to put my $sign as my multiplier because I would save $9, $2, and $7 on the 1-bedroom in the respective fees, and I would save $13, $2, and $9